Okay, I'm supposed to be recording now. Yep, we are recording. So let's complete. I was solving this problem, okay? We did the shear, and because time is up, I'm gonna finish the last part, and I'm gonna pause that last part of the problem. So let's do the moment. If we do the moment here, we start in the same way. You start with the point A. Is there any concentrated moment at point A? No, there's no concentrated moment at point A. So we can continue from there. Now, moment is the integral of the shear plus a boundary condition over there. Now, what do I mean by this? We're working on A, B, A, B. What I mean by that is this. The shear in that interval AB is this. So this is the equation for the shear. And this is what we are integrating now here. Okay? So the moment is going to be the integral of negative 40x plus 133.75 dx. And you do not put a negative sign here because then you will be using a double negation, a double negative, which makes it positive. So forget about that. The only way that you put the negative sign is when you study the shear. The negative sign is already included in the moment and so forth. So here you don't put any, you integrate this plus C. Now, what is C? Can you define C? C is yes in Spanish. What is C? Hello. Know how much is C? I didn't say that. I say, what is C? Ten already abandoned. Okay, what is C? No. Yeah, I know, but define C in the same way that I define C when I copy in the paper and I was talking about the shear. I say C is what? Come on, guys. Make me proud. No, come on. Let's see know what it is. I even copied the definition. And I can't find it. So weird. C is the value. Yes, is the value. Value of the moment at A, the beginning of the span, directly read from the diagram. And the reason I'm asking you to say that is because it's important, especially this part, read from the diagram. Because if I had concentrated moment here, it wouldn't start in zero, it would start somewhere else. Now, yes, it's zero, because it started in zero here. So the integral of this is going to be negative 20x plus 133.75x. And that should be the equation that we got when we did this. You see? Same equation. Integral and sections. And now you do the evaluation of these and you say, okay, my moment when x equals 0 is 133 0. And my moment when x equals 8 is negative 210, negative 210. You can plug the values and check it. Negative 210. I'm just copying from here because I know those values are correct. And it's the same equation. So negative 210, negative 210. Now what do we do? Please don't neglect infants, neglect dumb people instead. Now you come here and you say, okay, the shape of, I know that here, I need that value, and I know this here. Positive because it's plotted above, decreasing because the absolute value of the function is becoming smaller, positive decreasing, positive decreasing, negative because it's plotted below the axis. The absolute value of the function is increasing as I move left to right, negative increasing, negative increasing, like there. There you go. Do you need to calculate that point? Yes. What do you do to calculate that point? We already know x, so I put here moment at 3.4375. That's the x that we calculated before. Substitute that here, and then you're gonna get the value that 223.61, which is this value, 223.61. Right there, 223.61. And then we move on and we go and we say, okay, for the point B, is there any concentrated moment at point B? No, no concentrated moment at point B. So what do we do? Keep going. Keep going where? To BC. BC. Moment is the integral of the shear plus C. So moment is going to be the integral of the equation of the shear that we got for that span. The equation of the shear that we got for that span was this equation. Where are you? Equation. 20. Dx plus C. What is C? C is the value of the moment at B, read from the diagram, negative 220. Negative 210. Thank you. So moment is going to be 20x minus 210. That's my equation for moment. And you say moment at 0 is going to be negative 210. You say moment at the end, which is 3. Moment at 3. Moment at 3. That is equal to negative 150. You get these two values and you plot these two values here, negative 150, and then you realize that this is a straight line, so this is going to be a straight line. And finally, you go to the point C, and you do the same thing. I start with negative 150, and I find that moment concentrated there. That moment concentrated there of 150, acting in this direction. I complete this to see this side, and that means that it's going to be positive. So negative 150 plus 150 equals 0. It means that this is going to jump here, and then you go, yes. If I don't see this in your exams, I'm going to fail you. Just kidding. I'm going to fail you no matter what, so yeah, right. Just kidding again. Okay, any question regarding this method? Yes, no, maybe. Okay, now let's do the third method. I'm gonna do the third method in a different, stop recording.